Hi Frank, you recently interviewed Matt Kinsella, CEO of Infleqtion. What makes Infleqtion interesting is that it is not just building a neutral atom quantum computer, it also has quantum sensing products, including clocks, antennas, gravimeters, and inertial sensors. In this episode, I want to unpack what you learned from the conversation from an investor perspective. What was your biggest investor takeaway from the Infleqtion interview?
Thank you, Henny, first of all, for interviewing me. There were two big takeaways for me. Maybe three. Let's unpack that. So the first one, I think what is really important is that you have a real product and that you can sell something into the market. And what I like about Infleqtion is they focus not only on quantum computing for neutral atoms, but they also focus on quantum sensors. Think about quantum clocks, quantum radio frequency. Think about quantum accelerators and cryometers. And with that, what it basically does is this provides Infleqtion sales. And this could be a sales bridge. And if quantum sensing, this is a market that is real. And this week, Infleqtion also signed a contract with the US, with the UK, and with Australia to provide them with quantum sensors for the military. And quantum sensing was really real, and the benefit that this could give, it's a much shorter monetization path. And in quantum, it's also not only do you have the best technology, it's also do you have the cash to fund the research. And in that perspective, I think Infleqtion is interesting. So that was my first takeaway. They might have a sales bridge. The second takeaway for me was that their roadmap is really ambitious. So roughly around 2000 logical qubits, it's possible to do meaningful applications. They expect the first target is 100 logical qubits in 2028, and they expect 1000 logical qubits already in 2030. And this was sooner than I expected, so this is quite ambitious. Also quite a big step up from 100 to 1000. That's quite a significant delta. So that were my main takeaways.
Okay, and they work on neutral atoms. Could you explain neutral atoms in simple terms? Because it seems that it's a different way to come to quantum computing.
Yes. In Infleqtion's approach, many cesium and rubidium atoms are trapped inside an ultra-high vacuum cell. Lasers are then used to hold those atoms in place, arrange them into arrays, cool them, excite them, and engage them. Each atom can act as a qubit. And the attractive point of neutral atoms is that it's much smaller and all the atoms are identical. And with superconducting or spin qubit conducting, it could be that small differences in the chip or in the control that it could cause differences, and therefore they could drift. And you need to measure it, the quantum state, and see if it maintains coherence. For neutral atoms, all the atoms are identical. Sometimes people say they are God-given, and that is really helpful. And they are also very small. So with making arrays, you're not adding additional qubits. You put more lasers on it, and then, or not more lasers, but you're able to trap. It's able to make the atom smaller, and with that, it's very attractive to scale, and that is really interesting. So the scalability is quite good, but then you have another problem. And the problem is, okay, how do you control and how do you read out those atoms, especially if you scale them?
Okay, if this has so many benefits, why are neutral atoms just now becoming more important and not earlier?
Now, I think 2 or 5 years ago, the fidelity was much lower, maybe 60-70%, and now it's much higher, 99%. And the real benefit, what has changed the last 2 years, is the control and the readout. That's where neutral atoms really make significant steps forward.
Okay, that sounds good. What makes Infleqtion's business model different from other business models?
Now, we touched already a little bit about it. One thing what is different is that, first of all, they have the quantum sensing business, which could be earlier monetizable. The second thing is, what they do is they use two, for the readout, they use two atoms, rubidium and cesium. And if those are correlated, and what they can do is they can detect one, and if you detect and measure it, then the state collapses. But what's interesting is, because they use the two in parallel, then the other one does not collapse. And that approach I find is interesting and promising.
Okay. And what does the sensing business actually do?
Now, what they have is, they have, for example, quantum clocks, quantum RF, and quantum accelerators. And what that does is, for example, think about the Ukraine war. There, what you see with those drones, the GPS is being spoofed or jammed. And maybe take one step back. Quantum sensors are much more precise than normal sensors. So that is the first benefit. And secondly, is now with, for example, with the GPS system, a lot of things in our society depend on a GPS system. I wasn't aware of that. But in my interview with Matthew, I learned that, for example, clocks, the financial system, data centers, everything depends on timestamps. If the GPS system is spammed or disturbed, then it's not possible to do the timestamps on the right time. So, for example, if you do a financial transaction and the timestamps are not correct, a lot of things could dysfunction, and that is why. But Infleqtion, they won a contract with the UK government to replace the clocks.
Okay.
So that's the clocks. The second thing is RF. So with radio frequency, you work with an antenna, and with quantum RF, what they do, they use the atom as an antenna, and the atom is much more sensitive, and it can be much more smaller, and that's much more difficult to be spoofed or jammed.
Okay, you actually already answered my next question, but we continue on. How should investors think about Infleqtion's quantum computing roadmap?
Now, what's for me that what I find difficult is, I think that the roadmap is really promising. So the targets, 100 logical qubits in 2028 and 1,000 logical qubits in 2030 are really challenging. I find it difficult to judge that if they will succeed at this point of time, especially the step from 100 to 1,000. If they succeed, it's amazing, it's incredible. But I feel it's really ambitious. So what I would do is, I would say, let's take it step by step. And if they reach the 100 logical qubits, my conviction would go up. And also, if they make progress in the readout and the control of the atoms, and if they can get higher quality neutral atom qubits, then my conviction would go up.
What are the key bottlenecks you see for Infleqtion?
Now, the difficulty is, if you scale the amount of physical qubits, how do you control and read out all those individual qubits? So there have been research studies with MIT and Caltech proving 1,600 and even 6,100 physical qubits. So it is proven that these neutral atoms can scale. But can you also get the high logical qubits? And in order to get high logical qubits, you need better photonics, and you need better lasers, but you also need to read those out. But you also need very good error correction codes. And all those things need to improve.
Coming to these photonics, you mentioned integrated photonics in the interview. Why does integrated photonics matter? What is it?
Now, integrated photonics, that is light. And it's also being used, by the way, in AI right now. For AI, NVIDIA is moving towards co-packet optics. But that's a sidestep. Let's not go into there. But what is interesting is because NVIDIA is going there, what it does to the industry is that it increases the scale and it has the ability to lower. So more people are moving into the photonic space. And if more people and capital moves there, it brings more scale and that has the potential to lower the cost of the ecosystem. And it could attract additional talent. But why does it matter specifically for neutral atoms? It matters because lasers and photonics do the control. And they are central to the neutral atom technologies. And today lasers are critical to everything what Infleqtion do, and they're expensive. But the cost size could drop dramatically if there would be more scale.
Okay, that's clear. How does Infleqtion compare with some other companies in the area, like QEra, Atom Computing, and Pascal?
They all focus on neutral atoms, but the strategy is a bit different. So what is different about Infleqtion is that they focus on near-term monetization with quantum sensing, but quantum sensing is also based on neutral atoms. So it's still neutral atoms, but they do more on quantum sensing and they have some real contracts, some proof points. The other thing is historically they have been a supplier of vacuum cells and also lasers to other players in the industry. And the third thing is, what is different specifically on the technology is their approach of using both cesium and rubidium atoms, and they do that to make progress on the readout and on the testing. So normally, if you do measurement, so quantum technology is probabilistic, and if you measure the state, it collapses from probabilistics to either 0 or 1. So that's a problem, but because they have two kind of atoms, then one is collapsing, but they can still use the other to continue the computing. And I think that's an interesting approach.
Okay. What sectors and companies should investors watch if they have followed your interview?
Yeah, I like the neutral atom quantum computing companies like QEra, Pascal, Atom Computing. Second thing what I liked, I knew about quantum sensing, but it was not so much on my radar. And I think quantum sensing companies are also interesting. With GPS resilient timing, RF quantum. The third thing is, what is interesting is the photonics business. So is the scale really increasing in the photonics business, and does this lower the cost? The fourth is error correction. Is the error correction code, is it improving more for neutral atoms than for other quantum technologies? And the fifth is governments. What are governments doing? What is NASA doing? DOG and the ARPA. What are national labs doing? Do they have preference for one technology, or do they go for multiple technologies?
Okay. And what are the main investment implications you see?
Now, the main investment implications that I see is that the first, neutral atoms is really making progress. and they have a really ambitious roadmap. And if they execute on that, then quantum technology computing could happen sooner than I initially expected. And this could have material impact for society. Second, sensing might be the bridge business. So sensing could monetize earlier, and that could provide some healthy cash flows that they could use to lower relative the cash burn.
Do you see any risks? What are the main risks?
Yes, one of the main risks, there are two main risks. The first main risk is that they're not, in the end, I think the quantum computing business is the most important. And if they are not able to deliver on their ambitious roadmap, that is a risk. And that could cause lower trust in the company if they're not making it. The second risk is the focus, because the disadvantage of that you have multiple businesses is that you're less focused, and maybe competitors are more focused, and maybe competitors could innovate faster, because it's more difficult if you need to execute on multiple areas. It takes away management time.
What would increase your conviction in the chances of success?
For me, the first milestone would be, do they hit 100 logical qubits? The second milestone is can they get meaningful contracts on the quantum sensor business? And can the quantum sensing business be significant enough to fund the computing business? But also breakthroughs in the control and the readout of the natural atoms.
Okay, then my final questions. What should investors remember from this interview, from Infleqtion?
What I'm remembering from the interview is that they have a revenue bridge, which I think is unique and very helpful. And secondly, they have a very ambitious roadmap. And if they execute on it, Infleqtion has the potential to be one of the leaders within quantum technology. And third, quantum technology could happen earlier than people expect. And it will have profound impact for society.
Well, that's a new eye-opener. Quantum accelerating faster than you thought. So thank you for this interview. It was nice talking to you.